structural formula, condensed structural formula, and the third one is bond line structural formula, bond line structural formula. These are the three different types of organic compounds based upon structural representation. Let us take the first one, complete structural formula. So what is complete structural formula? Says to us the complete structure of an organic compound. Let us take ethane. So if you take ethane, how to represent its structural formula? Okay. So what is the chemical formula for ethane? CH3 CH3. Now this is considered as a condensed. What is that called? Condensed in the sense, okay, scrutinized. So condensed structural formula. Whereas complete structural formula, if you want to represent, you have to represent like that. So the main compound is carbon. How many hydrogens are there? Total 6 are there. And if you take hydrogens, I am mentioning here. Okay. So for first CH3, I have taken like this. For another CH3, I have mentioned like this, which is complete structural formula. Next one is, let us take ethene. What is that called? Ethene. So what is ethane formula? CH2 and double bond CH2, which is considered as a condensed structural formula. Whereas complete structural formula, you have to mention like this. Okay. Complete structural formula can be mentioned like this. Whereas ethyne, if you take the ethyne, let us take ethyne. So ethyne, formula for ethyne is CH triple bond, okay, CH, which is considered as a complete structural formula. And whereas condensed structural formula is, you can mention like this. Okay. Now finally methanol, CH3OH. You have to know the condensed formula so that we can make a complete structure of that specific compound. Now if you see, for carbon, how many hydrogens are there? 3 hydrogens are there. Okay. Now I am just writing or drawing a complete structural formula. And as you know that oxygen is generally present here, and it is OH group represented like this. So this is considered as a complete structural formula. Okay. So bond line structural formula. How to represent bond line structural formula? So if you take a bond line, structural formula, so how to write bond line structural formula? So bond line is generally represented like this. This is called bond line structural formula. Okay. For specifically, if you want to represent a methyl group, so you can mention methyl group by this bond line formula. In bond line diagram, atoms other than carbon and hydrogen are only shown. Other than carbon and hydrogen, only shown in the bond line structural formula. If they are bonded to heteroatoms like nitrogen and oxygen, which are considered as a heteroatoms, are also shown in the bond line structural formula. Okay. Now Structural formula, I would like to take some of the structural formulas. So here I am mentioning structural formulas. Okay, structural formula, butane. I would like to take first one of the gas called butane, CH3. How many carbons must be there? 4. So up to 4 carbons we have to write like this. And CH3, butane gas. It was done. And bond line formula is this one. Okay, so this is considered as a bond line formula. From each corner you can mention one of the carbon. So this is one of the carbon along with the hydrogen. Got my point? Okay. Butanamine. So one more example, let us take butanamine. So here also butane is there, along with that amino group is there. So CH3, CH2, 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 4 carbons I have gotten it, and finally amino group NH2 I have to mention. And bond line formula, so here at the end we got a bond line. At the end of the bond line formula we got amino group. What is that? Amino group. Now cyclopropane, one more cyclopropane. And cyclopropane is, so how cyclopropane generally looks like this. CH2, CH2, here also CH2. This is the cyclopropane structure. And bond line formula, it will be looks like this. Okay, and this is the bond line formula. And whereas for chlorocyclopentane, okay, another chemical I am taking here, chlorocyclopentane. Chlorocyclopentane. Okay, let us take a CH2, CH2, CH2. Here also I am taking CH2, and finally here I am taking CH. Chlorine I am taking here. This is generally a structural formula for chlorocyclopentane. And what is bond line formula? If you take the bond line formula, you have to draw like this, and chlorine I have to mention like this here. Got my point? One more example, cyclopropene. So cyclopropene. How to mention cyclopropene here? Cyclopropene, if you see carefully, CH2, here also CH2, okay, or instead of that, if you take a double bond formation, only one hydrogen we have to mention here. This one might be one hydrogen, so CH, and after that, and CH, one more CH we have to draw here. Carbon is going to make a bond with them. Cyclopropene bond line diagram you have to draw like this, and you have to mention a bond inside the structure. Cyclobutane. How to mention cyclobutane? So one more structure, cyclobutane. What is that? Cyclobutane. Butane means how many carbons will be there? 4 carbons will be there. Here also 4 carbons will be there. Here also one more carbon will be there. So total we have to get the 4 carbons. Butane. So butane structure we got a double bond formation you have to see, as you can see here. Okay, this is the structural butane. What is that called? Butane. Whereas bond line diagram, if you take the bond line diagram for cyclobutane, it will be generally like this with the bonding. And finally cyclobutadiene. Okay, cyclobutadiene. How to draw the cyclobutadiene? I'll show you here after rubbing. Please wait. So if you take cyclobutadiene, it will be commonly looks like this. Okay, and here also one hydrogen and carbon is there, and here also one more carbon, total 4 carbons we must get. Okay, next, and in between these 2 carbons a bonding must be there. Okay, double bond, and this is structural formula. And butadiene in bond line diagram, it will be generally looks like this. Okay, this is the bond line diagram for butadiene. Everybody understood the structures of what we can call carbon and their associated structure. Classification of organic compounds, I'll discuss with you in the next class.